right, here we go. Section 2.1, combine like terms. That's our target for today. By the end of this, you'll be able to combine like terms like a pro. Usually at the start of a unit, you're going to have quite a few definitions so that you know what you're talking about. And we all have kind of the same basis of a vocabulary in order to make all this stuff work. So let's get going on these definitions. An expression is a combination of integers variables and coefficients. Okay, so a combination of integers, variables, and coefficients. And what I mean by that, we're going to start looking at some variable expressions today, and things like x plus 4, x being a variable in this case, and we'll define variable in a second, but that would be an expression. Okay, it's kind of like in English, it would be the same as a phrase. It's not a full sentence, it's just a brief statement. So a variable is a letter or symbol that represents an unknown value or quantity. Just go with value. So typically in math we overuse the letter x. You know, if I were to write this same expression, my x plus 4, okay, that is my variable. I could have just as easily written it as z plus 4, or maybe even smiley face plus 4. Okay, it doesn't matter what you use. It can be any symbol or letter that just represents some unknown value. Okay. Now a coefficient, we use the word coefficient to mean a number that is multiplied by a variable. All right, so it's just a number multiplied by a variable. If we were looking at something like, maybe we double this whole expression up here, 2x plus 8, this 2 right here is my coefficient. Most of the time, hopefully, we get to see them as whole numbers or integers, but there will be times that it's a fraction or a decimal or something like that. Now, moving on, we have something that's called a term. Now, a term is an element of an expression separated by plus or minus signs. Okay, so elements of an expression separated by plus or minus signs. In the example above, 2x would be a term, and 8 would be a term. Now there's no variable on 8. It doesn't really matter. Okay, even if I had, let's say, 4x squared minus 5x plus 15, okay, 4x squared is a term, negative 5x is a term, and 15 is a term. Usually I incorporate the sign in front of the coefficient to include that in what I consider to be the term. Otherwise, I might lose this minus sign if I don't think of that as a negative 5x Remember, the difference between negative and minus, not a big difference at all. In fact, we'll just consider them one and the same. So I'm looking for a term being a coefficient, a variable, and a power if necessary. So variable, or coefficient, variable, exponent, those groups are going to be all the terms. So like terms, the last one here, like terms are, well, it's a term with the same variable and exponent combination. So it has the same variable exponent combination, meaning if I had something that was like, let's say I have my 4x squared and I have a minus 2x and a plus 5x squared and a minus 3x and maybe a minus 12. Okay, looking for like terms, I'm looking for the variable exponent combination that's the same. So here I have x squared, here I have x squared. Those two things are like terms. Okay, and same thing with the negative 2x. Can use a different symbol to signify that it's a different set of like terms. But there's two sets of like terms in those, or in that expression. So what we're going to be working on today are methods to combine those. If you notice, when we're talking about like terms, the coefficients can definitely be different. The only thing that has to be the same is the variable exponent combination. All right, so down below, first set of examples here, we are going to be identifying all like terms in the following expressions. So the way that I like to do it is I like to just kind of piece these things out. So here I have a 5x, here I have a plus 2y, and a minus 15z. So my answer would just be 5x, 2y, and minus 15z. Notice if it's positive, I don't write the plus sign because that's redundant. Okay, I have a 2x squared of an 15x, and negative 3x, and a 5. So 2x squared, 15x, minus 3x, or negative 3x, and plus 5. Okay, those are the four terms of that. Go ahead and pause the video and try the next two. All right, welcome back. Hopefully you were able to get those pretty easy. Just thinking about the chunks here, okay, it's separated by plus or minus signs. I have a negative 12y to the fourth, 15x to the third, and negative y squared. Okay, and on the last one here, I have the 8x, the 3y, the minus 10z, and the plus 11w. Those are all terms of that expression. All right, we're going to move on here, and we're going to get to start looking at what it means to combine like terms. Okay, combining like terms really just means grouping together terms with the same variable exponent combinations. All right, I want to look at one in particular that we just did, the second one. So I have a 2x squared plus 15x minus 3x plus 5. Now I have two terms here that have the same variable and exponent combination. Specifically, there's an x and no exponent. X, no exponent. Okay, so I'm going to group those together. Well, really all I'm thinking is that I have 15 apples and I take away 3 apples. These are oranges, these are bananas, so I can't do anything with those. but I can figure out how many apples I'm going to have when it's all said and done. All right, so we just write an equal sign, 2x squared. 15 minus 3 is just 12. So plus 12x plus 5. There I've combined like terms. That's basically what we're going to do today. Let's go ahead and turn the page and look at the next couple problems here. So we have 6 problems, and that's going to wrap our day up here. I'm going to go ahead and do a couple of them, and then you're going to do a couple of them. Let's see. What if I look at this first one? I don't have any other x's. Okay, that's my only x. Zoom in here, give you a better look. We can focus. There we go. So I don't have any other x's, but I have a positive 7 and a positive 8 there. 7 plus 8, that's 15. Pretty easy. That problem's done. We can move on. Okay. Here I have a positive 3 and a negative 10, and then I have an a all by itself. I really like to put the variable in front. You don't have to, but I like it a little bit better. So if I go 3 plus negative 10, that's like going 3 minus 10. It's going to give me a negative 7. Okay. I'm going to leave the left-hand side for you, or right-hand side over here for you. We're going to focus on these bottom two here. So let's look at this one right here. I have a negative 14, and I have a positive 1. Well, I have n's that are the same. Those are like terms there. Use a different symbol to show that I want to group those as well. So let's start off with the n's. I have negative 12 and negative 9. That's going to end me up with, I'm just going negative 12 minus 9, just negative 21. So I have negative 21 n's, and then negative 14 plus 1 is negative 13. That's my answer. Real easy. Okay, move on to this one right here. I have x squareds. Let's look for any more of those. Here's one, and here's one. I'm going to go ahead and write what that's going to be and show you another way that when the expressions get longer and longer, how I make sure that I get everything. So I have 15 minus 8. 15 minus 8, that's 7. So I have 7x squared. Now to keep myself straight here, I'm going to go ahead and cross those off because I've already dealt with those and I don't want to get caught up thinking about those again. Now let's look. We have x's. That's my next one. I have x's there. And 10 minus 3, that's going to be 7 as well. So plus 7x. Cross those bad boys off. And then we're left with just a plus 5 on the end. And that's my answer. Okay, no more like terms in this expression down here. So what I want you guys to do, go ahead and pause the video and work through those two problems. If you have to rewind it and get some ideas, go ahead and do that, but pause it now and go. All right, here we go. We're back. Now, like terms, 4x, negative 3x. 4 minus 3 is 1. 5 and 1. Well, use a different symbol. And yeah, we can cross those off too. 5 and 1 is 6. Hopefully you got that. Last one down here. I have a couple x squareds. Well, when I go negative 5 plus 5, that's going to give me 0. Whenever I get 0, I don't have to write it. Okay, they cancel each other out. I have 1y squared here. So I'll just put that, I'll start off with that. 3y squared. I have a 5x here. Better cross that out, and that's the only one I have. And then I have just a minus 3 left on the end. And that'll be what my answer is. Not a whole lot of combining there. But anyways, that's combining like terms. Go ahead and summarize the notes. Get the practice problems done and the application problems. Check those. and good luck on the mastery check. You stay classy out there. Alright, for the theme of the post-video entertainment on this unit, we're going to be looking at the top 5 football trick plays. And so for the first section, we're going to start with number 5 and we're going to count our way down. Number 5 is the Oregon wide receiver reverse pass back to the quarterback. I hope you enjoy.
He can throw. He tried to throw the first play of the Oregon State game. He comes back to Harrington, who has it. Touchdown! It works here tonight. Joey Harrington's touchdown.
Why this play works is that when you play man-for-man coverage, the only man that doesn't have a defensive player assigned to him is the quarterback. Number 3, Joey Harrington. That's why he's wide open, Kurt.
He looked like Steve Young back in '82 going in there for the touchdown. The ball is perfectly thrown here. We got to get Howie back there throwing the ball more often. And how about the athlete? How about the quarterback making the play?